My name's Jerry Zink. I'm an engineer at StoneAge. Today I'm going to show you our boiler tube cleaning system, how it's set up, how it operates, the various features that we've built in to make boiler tube cleaning safe and productive. This represents the mud drum on a package boiler. It has an elliptical manway, 12 inches by 15 inches diameter. This is the typical Babcock and Wilcox manway. This particular drum is 24-inch internal diameter. There are some that are 30 and perhaps 36-inch internal diameter, and this equipment could be used on those as well. Now, a mud drum has boiler tubes that come out radially from the drum itself, typically 12 rows of them, 3 or 4 inches apart, 2.5 inch tubes. My mock-up doesn't have the tubes in it yet. So the first thing to do would be to locate the tubes from the face of the manway so that when the machine is being used to address each of these tubes, it's very clear where the tube is. And here I've got a homemade probe which could slide in, go against the wall of the drum, and then by addressing each of the holes while reading the tape at the face of the manway, you can come up with a very accurate dimension of where the tube is. You just wiggle this probe back and forth, touch both sides of the tube and pick the middle number. So this number can either be written down or it can be marked on the tape with a magic marker. The drums that I've seen have two different spacings that alternate, like say 3.5 inch and then 4.5 and then 3.5 and 4.5. But in any case, it's a good idea to find out where the tubes are located, referenced from the face of the manway. The next thing we're going to do is place a rail inside the mud drum. Depending on the length of the mud drum, you would want that much rail. And that can come in one piece or in several pieces that get joined together, as I'll show you later. On the far end of the rail is a swiveling support that sits in the curvature of the drum. It has extendable feet which can be set so that when it's sitting on the bottom of the drum, this rail sits on the bottom of the manway, and this is level. When we put the machine in later that does the cleaning, there is a point of rotation which will end up centered exactly on the manway, 6 inches above the bottom of the manway, centered from side to side, and that will be the reference axis from which we address all of the radial tubes that come out of the mud drum. Now we're going to attach this clamp to the near end, right where the rail goes through the manway. These rods have hooks that hook on the inside of the manway, and then there's rail clamps that go on the bottom of the aluminum rail. These threaded rods draw the fixture against the face of the manway. Now I'll tighten the clamps that hold the rail into the fixture. With the short rails that I have for this demonstration, I left a joint right here. It's not important that there be a joint any particular place. Now I'm going to add some rail on the outside, which is where I will actually do the demonstration of the boiler tube cleaning, since you can't see it inside. When assembling this rail, it's important to have these holes that the gear drive interfaces on the right-hand side as you're looking into the boiler. This is an expanding pin that we've used for years at StoneAge to join this type of tubing. When you tighten this bolt, it expands laterally. We've recently improved it so that it has a directional feature that you can hold and get this in the correct orientation, as well as when you push it into the hole, it's got to stop so that it centers itself in the rail. So I tighten the bolt, expand the pin, which draws these two rails together right here at the joint. Take a quick look through the slots to make sure that they're free and open for the teeth of the gear to engage. So there's three components that comprise the boiler tube cleaner. This one is called a helix rotator. It can be applied to the rail by sliding it over the end. Alternatively, there are some wing nuts which can be loosened, and it can be set on the rail at any point without having to thread it over the end. So the job of the rotator is to orient this elbow in line with the tubes inside the mud drum. The next component is called a helix tractor. It's got a gear with teeth on it that engage the slots in the rail. Again, it can be fed on from the end or put on at some intermediate spot. It has a link to couple itself to the rotator so that these then form a train. The third component we're going to put on the rail is called a helix drive. It has two gears that intermesh and drive a hose. I will now insert the hose into the helix drive. This is a 5mm 4-layer hose, or a 5-4 hose. It's got our patent applied for armoring on it. I've put a cap on the end so that as I'm assembling this, if I happen to run the pipe threads into some metal object, I don't damage the threads. So that gets inserted through the helix drive. And the sprocket gets closed. After closing the sprocket, we will lock it in place with this bolt right here. Then this is a protective cover. Goes over the gears to protect people from getting caught in the gears or from foreign material from possibly getting jammed in there. Then the helix drive will be inserted into this hole. On the transporter, and the front snout will actually go into the tail of the elbow in the rotator. As I push it in, the hose will enter the elbow of the rotator. So now the end of the hose is here. I'm going to attach the hoses now to each of the three motors. Each of these ports is color-coded, and the ports on the control box, which I will show you later, have similar tags with the same colors. It's very important to keep material from getting into these motors. Most of the issues that we have with motors is not a problem when they are running, it's a problem that's caused when they are not running, when they are not protected by these caps, or if foreign material is in the hose that gets blown into the motor. So by blowing them out, then removing the cap and immediately putting the hose on the motor, I'm sure that I haven't introduced foreign material into the motor. These should be tightened with a wrench when you're actually going into a boiler in case these have a tendency to work loose. When we go into the boiler with this tool, it would be advised to couple all these hoses together with a tie wrap occasionally, just to keep them in a nice bundle on the right-hand side of the rail. I'm now going to attach the tape measure to this train in such a way that the center of this elbow is aligned with the end of the tape. There's a little clamp right here. Then I'm going to hang the tape over the control box, so as the machine goes in and out, gravity on the tape reel keeps the tape tight, and you can read the numbers right here on the face of the manway. In order to protect the end of the tape from being damaged, I'll just attach it back to the tape here. This collar that I'm loosening right here holds the elbow on the front of the rotator, and it must be folded a certain amount so that it fits through the manway. So by loosening this sufficiently that the edge of the snout clears the manway, roll it inside to where the elbow now has room to extend back out to its operating position. Then with the elbow inside, this collar again gets tightened. It has a wave spring inside it that allows some motion of this elbow in case it gets caught. So I'm going to tighten it down against a stop, but it still leaves the ability for the elbow to move. Now the end of the elbow is about 1 inch from the inside of the 24-inch drum, and the tubes typically project something like 1/2 inch, so there is a clearance between the end of the elbow and the tubes. Depending on field conditions, you may need to shorten or lengthen an elbow, and that's easily done by replacing the whole elbow. I've got 4 separate functions here. One is going to control a high pressure dump. This is the dead man kind of switch where I've got to hold it on in order to have the dump close and have pressure come to the tool. If I release it, then the pressure goes away. Then I've got travel. We also have rotation of the elbow. There is a stop right here on the elbow which hits the rail and allows this clutch to slip if I inadvertently over travel. And when I return, I can go back to a position without damaging the tool at all. Once this elbow is lined up, and that can be done just by looking through the manway at the first tube, within a mud drum, all of the tubes then in that row are lined up in the same orientation. So this function of lining up with a row happens only theoretically 12 times while you're cleaning a mud drum. Then the third function that I haven't talked about yet is feeding of the hose. So we have forward, reverse. You notice those move different speeds. Those are adjustable with two needle valves here, one for reverse and one for forward. I can turn down the forward feed to whatever the rate it is for the tool to clean the deposits you had. Retraction can be done at a separate rate, for instance a higher rate. If it's not important to clean the tube on the way out, then you can return at full speed. So I'm going to demonstrate putting on a 2-inch badger today. The beetle is another tool that we've made that would be useful in cleaning boiler tubes. We've designed a fairing to go on the back of the badger to give it a streamlined nature as it's backing up so that it doesn't catch on the elbow and, more importantly, doesn't catch on the end of the boiler tube in the steam drum. Those tend to be cut off square with no flare, and so this fairing here allows the badger to leave the tube and re-enter it without catching. Fairing's held on by an O-ring. I'm going to put it on the hose first. It's important to have washed out this hose and all of the hoses leading up to it from the pump so that any foreign material that might have been in the hose is removed before we put on the tool. Fairing is supplied in 2 halves that are installed on either side after the fitting has been tightened up. Then the O-ring is rolled up into the groove. The sequence of operations of rotating, translating, and feeding the hose are very important. As you could easily understand, if the hose is in a tube and you go to move with the translator or with the rotator, the hose will get caught in a bind and could be damaged. So it's always important to make sure that the tool is in the elbow before moving when you're inside the drum.